Okay, in this video I'm going to talk about using a slotted line to check voltage standing wave ratio to be able to determine the wavelength, half of wavelength and quarter wavelength. Before doing this, I remind you, if we have Smith chart here, so the electrical line between open here is or open to short here is lambda over 4, and from short to open again is lambda over 4. So from here open, if we start, we go to short and come back to open, we'll have lambda over 2 electrical length. Okay, all right. So what I have here, first I have connected my signal generator, which is minus 10 dBm power and 1.5 gigahertz frequency. What's the wavelength of 1.5 gigahertz? It is 20 centimeter. Okay, so wavelength of 1.5 gigahertz is 20 centimeter. Remember that, we will need this. And it's connected through this cable to here, the input of the slotted line through some adapters, and then this is slotted line. So this is a slotted line, and we are able to tune the length of this slotted line through this knob like that. And then we have a load here. Okay, so it depends what type of load you want to put. We see our voltage here. Okay, that's what we are going to see. Okay, so first let's connect a short here. Okay, I'm going to connect a short here. Here short is connected, and I'm going to show basically a null, a minimum here. This is what I'm seeing right now, the way it's connected. Okay, it's the minimum. How did I do a minimum? I just turn this knob. Okay, and it's at 8 point, let's say 5 almost. Okay, now I am going to turn this knob such a way, first I see a max here, and then again I see a minimum here. Okay, so let's do it. Let me turn this knob. This is a max. Okay, and then I'm turning it more and more to see a min. Here we go. Okay, now let's read the data. Right now it's 18.5 centimeter. Okay, how much was before? It was 8.5 centimeter. Let me turn it back here. It was 8.5 centimeter, and I rotate this knob, I turn it, and then 18.5. Here we go. Okay, so what does that mean now? So here what we are reading, to go from one minimum to another minimum, the macro concept is lambda over 2, as we have here when we have a short. So what we were seeing, a minimum voltage, a zero voltage almost. So from one short to go to another short, we have lambda over 2, right? And we know that lambda is 20 centimeters, so we expect to need 10 centimeter to go from here to here. That's what we saw here, that it was 8.5 and then we went to 18.5, and we could see the minimum or short again. Now let's change this load. Right now it's short. Let's connect the other side, which is open. So what are we supposed to see? So we were seeing a minimum, a 0 volt almost voltage. Okay. So when I'm putting an open there, then because open and short, they have lambda over 4 phase difference. Electrical length between open and short is lambda over 4. So instead of 0 now, if I connect, instead of short, I connect open. I was saying minimum at short, so after lambda over 4, I will see an open here. So I need to see a max voltage. So when the load was short here, I just replaced it. I just changed it, and I put a open here. Here it was, the oscilloscope was 0 or minimum. Now it's maximum. And that's the concept of lambda over 4, that you're switching between short and open. So right now I expect if I change this length from 18.5, lambda over 4, either going back or going forward, I'm not guessing, I believe I need to see, instead of this max, a minimum there, because I'm changing it lambda over 4. Okay, from 18.5, let's go to 13.5 and see what happens. Let's check it out. Here is 13.5, and that's what I'm saying. Okay, this is 13.5, and here it is. So this is the minimum. So that is concept of wavelength, quarter wavelength, and switching between loads. And now you tell me, if I open this and I connect a 50 ohm load here, this is a 50 ohm load, and I change the length, will I see any difference on the screen here? Will I see any difference? Right now this is 50 ohm. This is slotted line is 50 ohm as well. Everything is 50 ohm. Let's see. And this is my basically I'm changing it, as you see. But I don't see any change there. Why? Because it's already matched, and I'm just adding and subtracting some length, electrical length, but the whole system is matched to 50 ohm, and I won't see any mismatch on the screen to be able to measure wavelength from that mismatch, that it goes to max or min. Okay, this video is finished, and this was the concept of getting wavelength from VSWR concept.